Good morning. It's Thursday, March 19th, 2026. Today, we're not just tracking an update, we're tracking a fundamental shift in artificial intelligence. Welcome to the Daily AI News Digest. So, let's just get this out of the way. The era of simply talking to an AI, that's over. We've officially moved beyond just conversation. We are now in a new age of execution, where AI doesn't just respond to you, it acts. Everything we're talking about today revolves around one central theme, what we're calling the inference inflection. This is that precise moment where the industry's biggest problem is no longer about the brute force of training models. Instead, it's about the complex, high-speed coordination of autonomous agents actually getting things done. Think of it like this. The race isn't about who can build the smartest brain in a jar anymore. It's about who can put that brain to work most effectively out in the world. So first up, let's go inside the AI factory. We're going to start with the hardware foundation that was just unveiled at NVIDIA's GTC conference. This is the literal engine room for this new economy. Okay, so here we see the new Vera Rubin platform. And this reveals a really crucial shift in strategy. It's not just about a more powerful Rubin GPU for training. No, the key components here are the Vera CPU, which is specialized for really complex reasoning, and the Groq LP30. Now that is an accelerator designed for just one thing, ultra-low latency. This is the hardware that makes real-time AI action possible. And this slide really illustrates that major strategic shift. The old way was all about general-purpose chips. But the new way? It's a disaggregated AI factory, where every single component is purpose-built for a specific job in the intelligence lifecycle. NVIDIA isn't just selling you graphics cards anymore. They're selling you the entire assembly line for producing AI. The crucial piece of this puzzle is the integration. So after what's being called a strategic acqui-hire of Groq's team, NVIDIA has now baked their language processing unit, or LPU, right into the stack. And what this does is solve the latency tax. That annoying delay that makes agent-to-agent communication feel so clunky and slow. By controlling this tech, NVIDIA has essentially cornered the market on the speed needed for these autonomous systems to actually work together in real time. And the scale of this build-out is, well, it's just staggering. Meta has already signed a record-breaking $27 billion deal for this new Vera Rubin capacity. To put that into perspective for you, that is more than the annual GDP of some small countries. This isn't just some minor upgrade, it's a massive deployment of capital that signals a fundamental change in how data centers are being designed. So, with all this powerful new hardware getting plugged in, what can it actually do? Well, that brings us to our next story, where we get to see how this new infrastructure is enabling a whole new generation of software and, really for the first time at this kind of scale, physical robotics. Right, on the software side, OpenAI has just released its GPT 5.4 ecosystem, and you can really think of it like a corporate org chart for AI. You've got the large, expensive thinking model that acts as the CEO, doing the complex planning. It then delegates all the smaller tasks to these incredibly fast and cheap mini and nano sub-agents who are like the workers on the factory floor. It's this manager-worker dynamic that finally makes complex AI workflows economically viable. But the biggest surprise today came out of Beijing. That top-performing anonymous model on the leaderboards, the one codenamed Hunter Alpha? Well, it's been unmasked, and it's not from a dedicated AI lab. It's a 1 trillion parameter model from the hardware giant Xiaomi, and it's designed to be the brain for its phones and its electric vehicles. This proves that the barrier to entry for building these frontier models is absolutely falling. And this just raises the critical question, right? How does all this new digital intelligence translate from doing tasks online to actually manipulating objects in the physical world? Well, the answer comes from Berlin. The e-commerce giant Zalando just announced they've deployed 50 AI-powered robots to solve what they call the shoebox challenge, which is a notoriously difficult problem in logistics involving boxes with loose or detached lids. This is a landmark moment. This is AI graduating from the lab to solve a messy, real-world industrial problem. So how do these machines work? They operate on a pretty simple model. See, understand, act. First, they use advanced vision to identify an object. Then they use something called visual language action logic, which lets them reason about what they see in a very human-like way to process unpredictable situations. And finally, they dynamically adjust their actions in real time. They aren't just programmed, they are perceiving and adapting on the fly. But, as this technology accelerates out of the lab and into the real world, it's colliding with the hard realities of geopolitics and regulation.
And this really illustrates the deep fracture in global AI governance. In one corner, you've got the United States pushing for federal preemption. They want a single, light-touch framework to maintain their competitive edge. In the other corner, you have the European Union, which is enforcing its comprehensive AI Act, prioritizing safety and compliance above all else. What this means is that companies now have to navigate two fundamentally different legal worlds.
And make no mistake, the clock is ticking. This timeline shows the key deadlines for the EU's AI Act. And while some rules are already active, the really comprehensive requirements for high-risk systems, we're talking about things used in critical infrastructure or law enforcement, those become binding this August. Global companies have a choice: comply or you risk being shut out of one of the world's largest markets.
The friction is also physical. Geopolitical conflict has pushed oil prices over $111 a barrel, and that directly increases the energy cost to run these AI factories. And at the exact same time, intense demand for compute has driven cloud prices up by as much as 34% in some markets. The AI revolution, it turns out, is still anchored to a very volatile physical world.
Okay, finally, let's examine the astronomical financial stakes here and the fragile economics that are propping this whole revolution up. The numbers are historic. NVIDIA is now projecting it will sell $1 trillion worth of AI hardware by the end of 2027. This confirms we're deep in the build-out phase, where the vast majority of profits are flowing to the infrastructure providers, the companies selling the picks and shovels in this new gold rush. However, as this quote from a new Deloitte report highlights, this boom is creating a very high-stakes paradox. The entire semiconductor industry has become deeply, maybe dangerously, dependent on the continued growth of AI. And this visualizes the industry's vulnerability in a really striking way. AI chips now account for 50% of all semiconductor revenue, yet they make up less than 1% of the total volume of chips being sold. This kind of high-margin, low-volume dependency means that any cooling of AI investment, any slowdown in hype, could trigger a massive oversupply and a historic market correction. The entire industry is balanced on a knife's edge. Which brings us to our final thought. The foundational technology has arrived. The intelligence itself is becoming a commodity, and the agents are being deployed as we speak. So the challenge is no longer technical, it's operational. The question is no longer, can we build it? The question is, are you ready to manage what's been built?